All right. So our lesson today is still kind of staying in the same area of proportions and ratios and all that stuff that we've kind of been talking about over the last couple weeks or so. So this lesson is on what's called similar triangles. So we're kind of taking that idea of ratios, proportions, applying it now to shapes. So we talked about similar versus congruent earlier in the week. Similar, remember, it's the same size, same shape, different size. Congruent means they are the same shape and size, right? So what we're looking at with similar triangles is kind of being able to develop a way to say, okay, these are similar because they have the same ratio of the sides of their lengths, right? So for example, in this first example here, right? If I look at AB and DE, right? I have a length of 3 over here, a length of 6 over here. Well, 6 is how many times more than 3? Like, what would I multiply 3 by to get to 6? 2, right? So it's 2 times the length. So then I look at my other side, BC. I see that that's 4. EF is 8. 4 times what gives me 8? Four times what number gives me 8? 2, right? Right. So, and then 5 times 2 gives me the 10. So each side that I look at is proportional. It has that same ratio. I multiply something by the same number to get to a number over here, right? For every single side. And if that's the case, then the figures are similar. If it's not the case, then my figures are not similar. Okay. So what we're going to do is 2 quick examples here to kind of understand how the triangles relate, or their side lengths relate, what that ratio is, and then we'll be able to determine maybe what the missing side is from that, okay? So if I look at example 1 here, what I'm going to ask myself is, well, what do I have to multiply 3 by to get to 27? So 3 times what number gives me 27? Or you could think about, if I did 27 divided by 3, what's that going to give me? 9, right? Good. Is that the same thing for 54 divided by 6? What's 54 divided by 6? Nine also. So then I have to ask myself, well, what number divided by 9 is going to give me 4? Or you could say, well, what's 4 times 9? And that should give you the missing side length. Well, what's 4 times 9? What's 4 times 9?
Times 9.
36 from Iris and Shayna. Good. So 36. So that's my missing side length here. They're all proportional, right? To get from this number 3 to 27 multiplied by 9, 6 times 9 gives me 54. So then 4 times 9 should give me this missing side length, which is 36. In order for them to be similar, they should all have that same proportion or that same ratio. All right. We could work this way, where maybe we're trying to find a length from this triangle, the larger triangle, or maybe we have all the lengths of that triangle. We have to find the missing length of the smaller one, right? So we can do the same steps. 20 divided by 4 gives me what? What's 20 divided by 4? 5, right? Good. 25 divided by 5 gives me what? 5. Right? They're all similar, so they should all have the same ratio. So then I have a 35 over here. I'm trying to find this missing length. So I'll take 35 and divide that by 5. And I should get the same, or I should get the missing length over there for that triangle. What's 35 divided by 5? 7. Good. And then that is my missing length for that side. So on your Alex assignment, it'll ask you maybe, are these figures similar? They are similar if they have the same ratio, right, for each of those sides. So if you take one number over here and multiply it by a certain number, it should equal the same number throughout. Or you could divide from this triangle to this triangle. And then you could also find missing side lengths using that ratio or using that proportion to kind of help you out. Notice that in this one, right, if I divide all of them through, it should equal 5. Well, then if I take a length divided by 5, it'll give me the missing side of my other triangle. Okay, so you're going to see a variety of questions very similar to that. Does anybody have any questions, comments, or concerns about similar triangles? Okay.